A mysterious object billions of light-years from Earth is shooting out strong bursts of energy in a pattern that is similar to a heartbeat. A team of astronomers, led by the Massachusetts Institute of Technology, MIT, picked up what is formally known as fast radio bursts, FRB, which are intense radio waves that typically last for a few milliseconds. The newly detected FRB, however, persists for up to 3 seconds, about 1,000 times longer than the average. The signal, labeled FRB 20191221A, is currently the longest-lasting FRB, with the clearest periodic pattern detected to date. Although the researchers are unsure about the source, they suspect the signal stems from a radio pulsar or a magnetar, both of which are types of neutron stars, extremely dense, rapidly spinning collapsed cores of giant stars. Scroll down for video. The first FRB was detected in 2007. Sparking a hunt to find the source and hopefully uncover secrets about the space between galaxies by studying the signal's path. Daniele Micheli, a postdoc in MIT's Kavli Institute for Astrophysics and Space Research, said in a statement, "There are not many things in the universe that emit strictly periodic signals. Examples that we know of in our own galaxy are radio pulsars and magnetars, which rotate and produce a beamed emission similar to a lighthouse. And we think this new signal could be a magnetar or pulsar on steroids." Fast radio bursts, described as brief and mysterious beacons, have been spotted in various and distant parts of the universe, as well as in our own galaxy. Their origins are unknown, and their appearance is unpredictable. The discovery of FRB 20191221A was made by the Canadian Hydrogen Intensity Mapping Experiment (CHIME) telescope. CHIME, Canadian Hydrogen Intensity Mapping Experiment, situated in British Columbia, Canada, has 4 328-foot-long U-shaped cylinders, allowing it to detect signals from when the universe was between 6 and 11 billion years old. And this telescope has nearly quadrupled the number of fast radio bursts discovered to date. The pattern of FRB 20,191,221A's radio bursts was found to have similarities with emissions from radio pulsars and magnetars in our own galaxy. Radio pulsars are neutron stars that emit beams of radio waves, appearing to pulse as the star rotates, while a similar emission is produced by magnetars due to their extreme magnetic fields. The main difference between the new signal and radio emissions from our own galactic pulsars and magnetars is that FRB 20191221A appears to be more than 1 million times brighter.